Okay, so this video is going to look at what happens with ADH and how it helps keep the right concentration of in our blood. So keep in mind, remember homeostasis, if this was the blood concentration set point, so this is how concentrated you're supposed to be. You can either be above that line and be too concentrated, or you could be below that line and be not concentrated enough. So we're going to start with if your blood is too concentrated. All right, so your blood goes up. I am now here. I am too concentrated. So I have too much stuff compared to the water. So what does that mean? That means I'm just going to make up some numbers here. So let's just pretend I had 100 molecules of stuff. I'm going to call it stuff. It's a terrible non-specific word, but it could be salt, it could be sugar, it could be protein, it could be everything, right? In 200 water molecules. All right, so I'm going to just give it 2 out of 200. So I'm going to give it a concentration, right? I'm going to give stuff to water that's in your blood. So what does that look like? That means over here in your blood, so not that you have to, I want you to remember, blood is red. So this is our blood. So in our blood, we have a certain amount of water. So I have water in my blood, water in my blood, and I have water in the blood. I have water in my blood. There's water, right? So I have these waters. But I don't have a lot of water, enough water compared to the amount of stuff. I'm not going to draw the stuff. But I have this much water, and it's not enough. So we need more water in our blood to bring our concentration back down. So keep in mind our filtrate was moving this way, coming through our distal convoluted tubule, and then coming down our collecting duct. So this is the collecting duct. Right? This is the distal convoluted tubule. This happens in both places, but I'm only going to draw it in one specific place. So what I'm going to draw in over here, I'm going to draw in these receptors, these proteins embedded in here. So I'm going to draw more than one. There's another one. I'm going to draw one more, so that way you know it's not just like there's only one. There's lots of them. So we have, I know they're getting bigger as we go. It's my, my art skills. So we have ADH receptors here, and you also have them embedded here too. But we're just going to focus on here. So this is an ADH receptor. So that's what all of these are. So when your blood is too concentrated, your brain is going to release a hormone called ADH. So this ADH is coming from your brain. So this is going to be like step one. I'm going to put in parentheses. It's going to be from your pituitary gland, but for right now I'll just put from brain. So coming from your brain, you have your pituitary, your hypothalamus, and your brain's always like checking, what's the concentration of my blood? What's the concentration of my blood? Oh, the concentration's too high. So let me release ADH into the blood supply. It's going to travel all around the body, and this little key is going to bind into this little lock. So keep in mind, these are a very specific shape-to-shape match. So that ADH is going to bind into the receptor. So that is actually step 2. So ADH is released, ADH binds to these receptors, and what that does is that opens the door, so to speak, so that now water is able to leave our collecting duct and move into the blood. So keep in mind, this is our filtrate. Our filtrate's making its way here and down. And what does filtrate have in it? It obviously has urea, and it has some salts, but it still has quite a bit of water in it. So filtrate has water in it. I'm not drawing any of the other stuff. Once ADH binds to this receptor, makes this area more permeable to water. In other words, increases how water is able to move. So I think of this as like a door. Door opens. Here's my little lock. Opens the door. And now water is going to be able to move across. So step 3 is going to be open the channel, or open the door, but remember these are little channels, so we're going to open the channel. So now what's going to happen is water is able to move. Water is able to move. Water is able to move. So that's going to be step 4. This movement of water from the filtrate into the blood. So what does that do? Once water moves out of the filtrate and moves into the blood, what does that do to our blood concentration? If you add more water, so picture Kool-Aid in a pitcher, and then now you add more water into the pitcher, does that Kool-Aid become lighter in color or darker in color? Our Kool-Aid blood here is going to get water. It's going to become lighter in color. That concentration is coming down. So our blood concentration is going to decrease. So that's what's going to happen as a result. Your blood concentration decreases. So 5, blood concentration decreases. So hooray, you bring your blood concentration back to homeostasis. Well, let's just look and see what's left though. We're not done with the party. We've fixed our blood, but what does that do to our urine once the water left? Because remember down here we're going to be urine. All of these other waters that are left, that's going to be these guys. This is the water left in our urine. And so if this is the water that's left, what remains, these waters actually left the filtrate and moved into the blood. So as a consequence, the urine becomes more concentrated. Urine becomes more concentrated. So whereas the urine becomes more concentrated, your blood concentration decreases. So I'm just going to put that over here. Concentration decreases because the water went into it. Or it becomes, another way to say that is the blood becomes more dilute. That's an E at the end there. So your blood becomes more dilute, or your concentration of the blood decreases. So the water can only be in one spot. It's either in the filtrate or it's in the blood. Moved into the blood, dilutes the blood down, decreasing the concentration. But then that leaves less water in your urine, so you don't pee as much, and your urine is now more concentrated as a result. It'll be like a little bit darker, right? All right, so that is what happens once your blood is too concentrated. It's a hot day, you've been sweating too much, haven't been drinking enough water. Let's look down here. This is going to be what happens if, here's your blood concentration at set point. What happens if your blood concentration now is down here? If your blood concentration is down here, now what does that mean? This means your blood is too dilute. Blood is too dilute. It's not concentrated enough, right? So not concentrated enough, in case you're not sure what the word dilute means. So it's not enough. So that means, what if we have the same amount of molecules? We're still going to have 100 molecules of stuff, right? In this case, if it's too dilute, that means we have lots more water. We're going to say we have 500 waters. So notice this is not as concentrated. So if you did a percent, this is like 20%, and this is like, half. That's 50%. So this is definitely not as concentrated. So we have too much water in our blood here. That's way too much water. So what does that look like? Well, that means in your blood, you've already got too much water. So I'm going to add a whole bunch of waters into your blood, because that's what that is saying over there. This is saying there's already too much water in our blood. So what do we need to do? Do we need to take any more in? No, my goodness, we don't need any more. We already have too much. So what's going to happen is we are not going to have ADH. So no ADH, or a decrease in ADH. No ADH, decrease ADH. You have less, right? So that's going to be the first thing that happens. Decrease the amount of ADH that's released. Well, keep in mind we have our little receptor guys. Draw those guys in real fast. All right, so here are the receptors. If there's no ADH, is there anything to bind here and open the door? Nope. So therefore, that's going to be number 2. We're not going to have nothing to bind, so nothing to bind. So if nothing binds there, there's no key for the lock, no channel opens, nothing to bind, channel stays closed. So if the channel stays closed, what does that mean? See, I had 1, 2, 3, 4, 5, 6 that were here before in the top example, so I want to be consistent. So 1, 2, 3, 4, 5, 6, so we have 6 again. So if the channel stays closed, can this water get through? No, the water cannot get through. So nothing moves through. Therefore, as a result, water stays in the filtrate. Well, if water stays in the filtrate, what does that mean it's going to do? That means it's going to stay in the urine, right? Water stays in filtrate. So actually, hold off on that number up there. I'm sorry. Let me go back up to here. So that means up here, we're not going to move. Actually, redo. It's going to stay in the filtrate. Once it stays in the filtrate, this means it's going to be part of urine. Be part of urine. So your urine is going to be very dilute. You're going to have lots of water in your urine. Now over here, what's going to happen to this water over here? I'm going to make him number 5. This water over here will get used with time, right? Water in blood will get used by cells over time. So cells will use them, chemical reactions use it. Eventually this water is going to be used. So if you start using water that is in the blood, what does that do over here? You take out the water in your blood, you start moving back up. So that is going to be 6. So as we use this water from the blood, cells will take it out. We're going to bring our concentration back up, and now we're getting back to homeostasis, right? Does that make sense? Hopefully it does. So again, if you're too high, release lots of ADH. So therefore the water moves into the blood and decreases that concentration, and you'll have less water in your urine. Versus you have too much water in your blood already. You're like, whoa, I drank a bunch of water. I don't need any more over here. We need to keep it in the filtrate so it becomes part of the urine, and then you pee it out. So notice these are always opposite. If your blood becomes more, if your blood concentration decreases, the urine concentration increases. If your blood concentration is going to, notice, go back up, that means your urine concentration is going to go down. These are always opposite to each other. So the water can only be in one place or the other. So it's either moves into the blood, and therefore it's not in the urine, or it stays in the urine and does not move back into the blood. And that's all. Sorry about that. That is always just dependent on this hormone here, antidiuretic hormone. If you have any questions, I do have another type of model that we can talk it through. Please make sure you come and see me.